Okay, this is how it works. First, to determine how much electrons they will lose or gain, you gotta look at the group. In the group, you gotta look at the ones digit. If the ones digit is a 1, a 2, or a 3, that's how many electrons it has on its last level. Now, if it is a nonmetal, it wants to gain. Nonmetals are women and they want to gain electrons. Metals are men and they want to give. So if a metal has 3 electrons on the last level, it wants to give 3. They all want to gain to become noble gases. Noble gases cannot lose or gain since they are full. Okay, let's do this. I'm gonna do this without the drawing, so it's just like a trick that the teacher taught us. Alright, so you first find out how much the one element wants to gain or lose, then you find out how much the other element wants to gain or lose, then you do a crisscross, and that is your chemical formula. Now, if you're doing it with the drawing, if there's 2 H's, you would put H2, the 2 as the subscript, and if there's 1 O, you would just put O. Alright, so if the subscript is equivalent or it's equal or whatever, you have to simplify the subscript. The ionic bond is a giving bond. That is when a metal and a nonmetal bond. The metal gives over electrons to the nonmetal. The metal will give over the amount of electrons that are needed so the nonmetal could be filled to capacity. The covalent bond is a sharing bond. That is a bond with both metals share their electrons so they could both be filled to capacity. No bond is pretty straightforward. That just means they can't bond since one of the elements are already filled, or the other element is a noble gas. It's pretty straightforward. So let's go over why atoms want to bond. The reason why atoms want to bond is because they want to be in group 18, the group with all the noble gases. They want to be filled up with capacity. That is why elements bond. Okay, let's go over drawing the bond and the compound. Okay, I'm going to do an example. Now for this one, I do not know how to draw like the arrows or stuff, so I will pick another one to show that because we haven't done something like this in class, but so this is how you do it. So I picked the elements Mg, and I picked the elements N. So N has 5, it needs to gain 3 to get to 8. And Mg has 2 on its last level, it needs to lose 2 to get to 0. Okay. When you put it right here, N needs to gain 3, so the 3 would go over here, and Mg needs to lose 2, so the 2 would go over here. So this is what the formula would look like. Now, let's go here. Let's start. So you do Mg has 2 electrons on its last level, and N has 1, 2, 3, 4, 5 on its last level. Now N needs to get to capacity, and Mg gives its 2 over to N, but there's still an extra one left. So they call on another Mg to give, but the Mg still has another one left. So it calls another nitrogen to give it to. But the nitrogen still has two left. So it calls another Mg to give both. So that's how that would work for the example. Okay. All right, so hydrogen needs to gain one. And potassium needs to lose 1. So how would that look like? So hydrogen 1, potassium 1, and just do the crisscross method, and you get K and H. All right, so how would you draw that? All right, let's go over it. H, that's what H looks like because it has 1 on its last level. And K has 1 on its last level. Now, H wants another one. I'm just going to draw the X right here. So K just gives it over, and that's how it would look like. And then for the bond, you would draw H and K. And that's what it looks like. And oxygen, I'm pretty sure we pretty much all know what that compound is. So if there's 6 right here, 6 plus what needs to gain to 8? 6, 7, 8, 2. So helium needs to gain what to get to 2? It needs to gain 1. All right, so H, gain 1. O, gain 2. H2O, H2O. All right, so let's draw that. The H is with the 1 on the top, and the O is with 6. 1, 2, 3, 4, 5, 6. All right, so now it has 2 empty. All right, so the hydrogen asks to share, and it says, yes, of course, share with me. So the hydrogen goes over here and goes like this. So the hydrogen, one of them is over here, and it shares with this. So it's kind of like this. Let me just draw it out. So let's pretend one of it's over here, and it uses this one too to fill it in. All right, now it still has one missing, so it calls another hydrogen. Hydrogen says, can I share? And it says yes. So it goes over there to position itself, and it uses this one and places its other one that it has right here. So that's how you would draw the drawing. And for the compound, you would write. All right, and then if you want to draw it differently, I'm pretty sure it's like H double line O double line H. So I'm pretty sure that's how you would do it. I'm not so sure about this, but I know this is right. Okay, we're going to do one, and we're going to pretend that we have no idea the periodic table of elements. It is not involved in this problem. All you see is this, and all you know is that H needs to gain 1, and it has atomic number of 1, and Mg has atomic number of 12, and needs to gain 2. That is all you know. So how would you draw that out if you see it like this? So H, we know that it has 1 on its last level, and Mg, we know that it has 2 on its last level. Hydrogen needs to gain 1, so Mg will give it. And H, it has an extra 1, so it needs another H, and it gives it like that. So that's how you would draw it. Alright, how to tell the different elements. So first of all, the two H's are the same, and then the O and the Cl are different. I mean, that's pretty straightforward. Let's just go back to simple math. So 3 times H, 3. 3 times H with a subscript of 3, that would be 9. So 3 plus 9, 9, 10, 11, 12. So there's 12 H's. And 3 times Cl with a subscript of 1 is 3. So there is 12 H's, 3 Cl's. The total is 15. Okay, this is not an equivalent equation because as the Ag and the reactants and the Ag and the products are not the same. The Ag and the reactants has 2, but the Ag in the other side only has 1. And the O on the reactants has 1, but the O on the products has 2. To make this equivalent, we are going to do it right now. Okay, this is how to make it equivalent. You will add a coefficient of 2 to the first side to make the Ag 4 and to make the O 2 on the other side. And you will add a coefficient of 4 on the other side to make the Ag 4, and the O on the product side is perfectly fine. So that's how you make that one equivalent. All right, I broke it down on the screen, and so they all equaled each other, so that's how you could tell it the same. I tried to make it so you could follow my work as easy as possible, and that's it. The equation needs to be balanced so it follows the law of conservation of mass/matter. Some of the things of the law is that matter/atoms can neither be created or destroyed, and atoms can only be rearranged. Alright, that is the end of the video. I hope it taught you something new. Bye!